So we are into the 60 seconds. Give us a chance to say hello to our friends at SES in Luxembourg, our friends at ECA Abu Dhabi, to the Airbus Defense and Space teams in Toulouse, to the orbital teams in Virginia, to our industrial partners, ECA and CNES, and to all of you following on the internet. We hope you're enjoying it. If you're not settled in, pull up a chair and enjoy. We're going to cut away, let you listen to the DDO, and he'll call out the final seconds.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top. Allumage moteur Vulcain. Allumage EAP, top décollage. La propulsion est nominale.
The DDO says all is normal, and you saw at 1920 local time, and right on time, Ariane 5 began her mission, lifting off from the ground here in French Guiana with a lot of fire, heading into the clouds with 2 new satellites.
La propulsion est nominale.
The 2 boosters are providing 90% of our thrust right now, propelling the launcher along her trajectory at an ever higher velocity.
Les paramètres bord sont conformes à l'attendu.
773 tons at liftoff. And to get that sort of mass off the ground, you need a lot of push, and push we have. She's burning 5 tons of fuel per second, 2.5 tons per second in each booster. And the core stage is burning another 300 kilos of fuel per second. Fine shots of Ariane 5 rising into the sky. She looks just like a comet. Ariane 5 now following the program in the onboard computer, as the DDO says, all is normal on board, which gives the orders including stage separations, which we'll soon see. We're in the first of 4 flight phases. We'll describe each in turn so you can follow Ariane as she heads east across the Atlantic. Right now, the first flight phase, the single first stage engine and the 2 boosters are burning. The boosters will each consume their 240 tons. In just over 2 minutes, in about 15 seconds, they will be extinguished, and you'll hear that from the DDO. This first flight phase using both cryogenics, very cold fuel, and storable propellant. Cryogenic propulsion offering certain advantages, reignitable, more precise performance. And we move to the animation. In just about 2 seconds, you'll see the booster separation.
Séparation, étage, accélération à poudre.
Confirmed by the DDO. They will fall 500 kilometers from the shore in a protected area. Nice shot of it there on the onboard camera. There's another booster on the port side, of course, out of camera range. On the bottom of your screen, on the left our altitude, on the right our speed. Speed we need for satellite separation, roughly 9 kilometers per second. That's 9,000 kilometers an hour. You see where we are, just over 2 kilometers an hour. We have a ways to go. So keep your eyes on the numbers, and when we near the region of 8-9 kilometers per second,
Le pilotage est calme.
You know we will be getting close to separation. We're getting close to separation of the fairing, which is next up. That's the pointed nose cone on the right of the composite. You can see the logos on the outside of the fairing placed there by the customers. That's something of a tradition. There's separation on time.
Lagage de la coiffe.
Confirmed by the DDO. And on the onboard camera, you see there's another half which falls away again out of camera range on the starboard side. Revealing to the elements our first passenger, SES-14. That's the blue and gold box on the right. We can separate the fairing now because we're out of the dense layers of the atmosphere over 100 kilometers up. There's neither friction nor heating, which could disturb the passengers. We can also discard any dead weight to maximize the launcher's performance. Fairing, remember, weighs almost 2.5 tons, so we can get rid of it now. With its family of launch vehicles, Ariane Space is the reference, providing launches of any mass to any orbit at any time. And Ariane 5, of course, the heavy lift launcher, the two other members of the family, Soyuz and Vega. Next up in our series of films, one on our first passenger, SES-14.
SES has been a very faithful customer of the Ariane family of launch vehicles, with more than 40 satellites entrusted to Ariane or to Soyuz. Our launch contract was initially for SES-12. However, 6 months ago, SES decided to launch SES-14 instead of SES-12 on Ariane 5. We were able to accommodate this request in the short time left till launch, in spite of the particularities of SES-14, such as the need for a purging system up to liftoff for the NASA Gold payload on board SES-14. SES-14, built by Airbus Defence and Space in Toulouse, is the second spacecraft in the Eurostar 3000 EOR series to be launched. It will rely on its electrical propulsion system to reach its final orbit, as both satellites on this launch use electrical propulsion, and thanks to the performance available on the Ariane 5 vehicle, we have been able to optimize the delivery orbit, hence reducing the time needed for the satellite to reach GEO.
On the right, as DDO says, all is normal, this SES-14. Under that, the black bell-shaped structure is what we call the Silda. That's the carrying structure. Underneath that is our second passenger. We're in the second powered flight phase, the single-engine core stage burning now, the boosters having done their work. All of Ariane's trajectory has been designed to be followed from the ground. The launcher is sending radar and telemetry back, and a network of stations keeps constant watch on the health of all her systems. We'll start receiving that information in just a moment. Telemetry is launch vehicle data, information on 1,500 parameters being collected and transmitted back to the ground. We had a look at our first passenger, now a first look at our second customer, Alia 3.
ECA contracted the launch of Alia 3 satellite with Ariane Space in September 2014. A year later, the mission analysis was initiated. The main objective was to consolidate the launch mission profile with the satellite-specific features. Alia 3 is manufactured by Orbital ECA and is based on the new Starfree platform. It is the first of its kind to be launched with Ariane 5. Throughout the years, ECA has maintained regular exchanges between Orbital ECA and Ariane Space to prepare the launch campaign and refine the launch mission. In summer 2016, Alia 3 was allocated SES-14 as co-passenger. The overall mass of the two satellites remains well below Ariane 5 lift capability. To benefit from Ariane 5 full performance, a specific injection strategy is implemented for this launch. With Alia 3, ECA will increase their in-orbit fleet to 3 satellites, thereby confirming their role as a global operator in government and commercial communications.
We will soon be picked up by our first downrange tracking station located in Natal over the border in Brazil. The Brazilian Defense Department runs the station for CNES in an agreement with the European Space Agency. It'll see the lower stage burnout and separation. And what do the ground stations like Natal do with all this information? Well, customers get immediate data on their spacecraft, and that's so important. Some data are analyzed in real time. Others are studied after the flight to learn how the vehicle performed on its mission. A complete analysis is carried out about a week after each launch. So you can imagine the enormous archives this gives Ariane Space, a wealth of technical information going all the way back to the first launch of Ariane 1, 1979. We are awaiting confirmation of 3 events: extinction and separation of the lower stage, then ignition of the upper stage. That's due just in about 15 seconds. Everything is all right on board, as the DDO says, the launcher performing flawlessly. Tonight, a standard double launch, 2 communication satellites. As we wait, there you see the cutoff of the lower stage. Separation of the lower stage And
Séparation EPC.
Ignition of the upper stage. These three commands given by the onboard computer in about 13 seconds. So we are now into the third and final powered flight phase, the single upper stage engine that will burn until plus 24 minutes and 44 seconds, or 16 minutes roughly. The job of the upper stage is to take the satellites to their injection point, position them for separation, and then release them. That is its propulsion role. But she also has a second role, and that comes during Ariane 5's ballistics phase. That comes later on in the flight, and we'll have more on that coming up. You're looking at the people from the Alia 3. Alia 3 arrived here in French Guiana November 29th. Hi there. It went right to the satellite preparation buildings here at the CSG, known as S5 for its checks. SES-14 came about a month later. December 22nd began its tests. All that preparation usually takes about a month. And you heard about it in the first film on the launch campaign. And we're going to go to another look now at our second passenger, Alia 3. Back with more of the mission in a moment.
Today is an incredibly proud day for Yahsat and the UAE as we have launched our third satellite, Alia 3. This achievement allows us to continue our dream of providing connectivity to the rest of the world and helping these parts make sustainable changes to their lives for the better. Yahsat celebrated its 10 years anniversary in 2017. Yahsat is proud to have customers in 55 countries around the world and to be providing DTH solutions to over 50 million viewers in the region. It gives us immense pride to be serving the Milsatcom's needs of the UAE Armed Forces as well as the government sector. Yahsat is also proud to be the leading satellite broadband provider in Africa today. Alia 3 is a Ka-band satellite dedicated to expanding our broadband services to 19 additional markets in Africa and marks our first entry into Latin America, specifically the Brazilian market. In few months, once fully operational, Alia 3 will enable Yahsat to empower 60% of the African continent's population and 95% of the population in Brazil.
We're going to look closer at Alia 3 in the next couple of films coming up. But before we do, I just want to make another point on the propulsion systems on Ariane 5, which is so interesting, using both cryogenics and solids. Cryogenics, as used in the main stage, as you saw, more efficient, basically, than solid propellant, which is used in the boosters. Basically, solids are for getting us off the ground, away from the pull of the Earth. Cryogenics, on the other hand, are for more precision orienting of the vehicle. And, of course, they allow the stage to be reignited, but that's in the other version of Ariane, not in the one being used tonight. One advantage on the other side of storable fuel is that it doesn't evaporate as much like cryogenic fuel. Storable propellant is also cheaper, so Ariane 5 a mix. Our attention once again on Alia 3 for a more detailed explanation of the satellite and optical ATK.
This is a proud day for all of us with the launch of Alia 3. Alia 3 joins Alia 1 and Alia 2 to provide services for one of the world's most exquisite service providers, Yahsat. Its weight is approximately 4,000 kilograms, and it represents a technology step greater than any one that we have taken in the last 21 years of our product line. One of the most notable improvements is electric propulsion. Electric propulsion enables very efficient station keeping and has also enabled increased payload capacity. Alia 3 supports a very sophisticated Ka-band payload, which consists of 53 user spot beams, 0.7 of a degree, providing services to Western Africa and Brazil, and 6 switchable gateway beams.
Yahsat has been a wonderful customer to work with. We are proud of this relationship, which is based on trust, transparency, and teamwork. The Yahsat engineers are brilliant and a pleasure to work with. Their pride and commitment to this project are unparalleled, and that has translated to everything they worked on and accomplished. During this program, in addition to the dedicated Yahsat program team, we have cycled about 18 Yahsat trainees who have spent time at our Dulles facility working on Alia 3 and learning throughout the process. This on-the-job training has been one of the highlights of this program and has increased our appreciation of how talented and dedicated these engineers are. Orbital ATK has also joined YASAT and Masdar Institute in sponsoring a master's degree concentration in space systems and technology. The program is the first of its kind in the Middle East. The first class of aerospace engineers graduated last year, and the program has reached great visibility within the UAE. On behalf of Orbital ATK, I would like to thank YASAT for their confidence and trust in us. We are honored to be part of this exciting journey, and we wish Aliyah 3 successful launch and excellent performance in orbit. Good luck, Aliyah 3. Bitawfiq, inshallah.
I said optical ATK, didn't I? Introducing that film. Terribly sorry. Of course, it's orbital ATK. Put it down to all the excitement. Terribly sorry. 10 minutes to go in the upper stage burn. During the film, we were picked up by our next downrange, tracking station, Ascension Island. That's a tiny island in the South Atlantic, 10 square kilometers, belongs to the UK. NASA had a station there till 1989, and when they closed it, ECA, the European Space Agency, decided to build its own. Our first passenger, SES-14, is the 53rd satellite launched for its operator, SES. SES is an old friend of Ariane Space, as we mentioned. Our first launch with the group dates back to 1988. Our next film looks again at the SES group.
SES-14, a hybrid satellite, is equipped with both wide beams and high-throughput spot beams that will enable high-quality video delivery and enhance connectivity to the Americas, the Caribbean, and North Atlantic region. SES-14 will accelerate the development of SES's expanding cable neighborhoods in Latin America. SES-14 joins other SES satellites in the region to meet the exponential demand for in-flight connectivity and connect airplanes flying on some of the world's busiest aero routes. SES-14 will capture new opportunities in maritime, broadband, and cellular backhaul, and enable governments with secure and reliable connectivity networks. The satellite will also carry a NASA-funded hosted payload called GOLD, or Global Scale, Observations of the Limb and Disk. This hosted payload provides unprecedented imaging of the Earth's upper atmosphere to help scientists study the boundary between Earth and space.
SES-14 is a big step forward for SES. It's a large satellite in terms of capability and in terms of mission. It's around about 16 kilowatts, so that is a big, powerful spacecraft. With SES-14 being a full electric satellite, it allows us to use the available mass to build a far more sophisticated payload, which in fact allows us to combine what would have been two conventional satellites into one. This is our first satellite that actually has a process payload. Around about 25% of the capacity carried on board this spacecraft runs through a processor, which allows us to reconfigure dynamically exactly where our bandwidth and where our power is being offered, and as and where it is required by our customers, and allows us to offer a far more flexible service to our various different customers in the region.
She's about to be picked up by our next downrange tracking station in Libreville. That's on the west coast of Africa in Gabon. Until Ariane 3, the last downrange station was in the Ivory Coast. Akakro was the site. For Ariane 4, we needed a new station farther east, so set one up 40 kilometers from Libreville in 1986. The station receives telemetry for about a quarter of an hour, and we'll see the upper stage burn out. Both satellites, by the way, are on power, launched with the power on. We learned from Martin Hallowell this morning that SES-14 has been on since last night. You heard about the NASA payload flying on SES-14. Here's a chance to learn more.
Floating hundreds of miles from Earth, astronauts get a unique perspective of our planet. While they might recognize landmarks, space is the only place they can see the very edge of our planet's atmosphere. This uppermost layer of Earth's atmosphere, the ionosphere, also overlaps with the very beginning of space. It's the job of NASA's new mission GOLD, the global-scale observations of the Limon Disk instrument, to study this region that affects humans every day down on the ground. The ionosphere is a crucial layer of the atmosphere through which our communications and GPS signals travel. And when this region changes, it impacts those communication signals. Changes can occur above this region from the sun's activity, also known as space weather. Changes can also occur below from Earth's weather. GOLD connects the dots between how space weather and Earth's weather shape the upper reaches of the atmosphere. But this region isn't easy to study. The ionosphere spans roughly 60 to 400 miles from Earth's surface, which is too high for aircraft and scientific balloons, and the lower regions are too low to easily study with satellites. What are attainable, however, are the swaths of red and green light named airglow shining out from the upper atmosphere. Taking advantage of our planet's natural glow is GOLD. The GOLD instrument, which is about the size of a mini-fridge, is hitching a ride on a commercial communication satellite, SES-14. The satellite's orbit lies 22,000 miles above Earth, where it can record images every 30 minutes in ultraviolet light to monitor changes in airglow across the globe. These images give information on the temperature, density, and composition of particles in the upper atmosphere. GOLD joins a host of missions studying the very nature of space, which is crucial for our journey to understand our solar system and beyond.
Richard Eastus, the principal investigator for the GOLD mission, is here. He's on hand for the launch. He told us this morning that eventually data from GOLD could help improve our weather forecasting, particularly in predicting storms. So, an aid to aviation, among other sectors. 4 minutes to go in the upper stage burn. Some numbers. This launch is the 295th mission performed by the Ariane family of launchers. SES-14 and Alia-3 are the 571st and 72nd satellites launched by Arianespace, and the 137th and 38th to be launched on an Ariane 5. Our next film looks at Airbus Defence and Space, builders of SES-14. During the film, we were picked up by our last downrange tracking station in Malindi, Kenya, on the east coast of Africa. There are actually 2 stations here. Like Ariane 4 needed a new station, so did Ariane 5, so we opened a 5th tracking station for Ariane 5's second launch in 1997. It receives the data the longest for 3 hours. After liftoff, it'll see the upper stage burnout and both satellite separations. And we are coming up on extinction of the upper stage engine, about 5 seconds. You'll hear the DDO call out that milestone, and you'll see the nozzle shut down on the left-hand side. There we go, right on time. So with the upper stage engine shut off, we have entered the coasting phase. But that doesn't mean that nothing is happening. The composite is being maneuvered and spun in a series of 20 operations, roughly. They range in time from a few seconds to a few minutes, and you can see the composite being moved around there. We do this because we have to separate the first satellite in one direction, then the Silda, that's the black bell-shaped structure in the middle of the composite, in a second direction, and finally our second passenger in yet a third direction. The attitude and control system uses small thrusters to perform these maneuvers, and that's what's going on right now. Another place that's very active tonight is called the CVI, the Quick Look Telemetry Display Control Center. These teams have all the means for receiving, processing, storing, and analyzing all the data coming in from the ground stations along Ariane's flight path. Another advantage of the French Guiana site, besides the water, was nearby hills, where we can receive the telemetry from the launcher. And the CVI is stationed atop a hill not far from Jupiter. And right now, these teams are following and analyzing all the key flight data coming in and reporting the flight status of the launcher back to the teams here in mission control, all part of the great information flow from points across the base back to mission control here in Jupiter. We're coming up on confirmation from the DDO on separation of our upper passenger, due in just a few seconds. Half a minute, I'd say, plus 27:03. As we approach separation, it's always a moment of high concentration. The teams have gone through these procedures before, but it does call for tremendous focus. You don't want to say tense. Focused, I think, expresses the idea. Concentrated. All eyes are on the computer screens. All ears on the phones, awaiting confirmation of our satellite separation, SES-14. And we saw it on the animation. We're waiting for confirmation from the DDO. Well, apparently we have confirmation. First good news of the evening. Successful separation of our first passenger, SES-14, right on time, apparently. Just off the east coast of Africa. And you notice the people in the hall here in Jupiter politely holding their applause because, of course, the mission is not over. We have to separate our final passenger, Alia 3, still 8 minutes to go in Ariane's mission. SES-14 separated 3-axis stabilized, the 3-axis stabilized manner, different from our second passenger, as you will see. We mentioned the satellites are separated when the launcher is moving at roughly 9 kilometers per second. Why? Well, this is close to the speed at which the Earth turns, 10 kilometers per second, 36,000 kilometers an hour. When the satellites get to that speed and to their proper altitude, they can then produce coverage over a specific geographic area because they're in what is called geostationary orbit. They appear to hover over the region, but they're actually flying at the speed of the Earth. Our next film explores the relationship between Arianespace and SES.
SES-14 is the 41st GEO launch we have with Arianespace, and personally, it's my 4th launch campaign with them. I would like to thank Arianespace, CNES, CSG, Airbus, and LASP for their collaborative work throughout the full launch campaign, and particularly during the Christmas and New Year's time. To provide you a bit of the next step, 5 minutes after separation, we will receive the telemetry and deploy SES-14 solar arrays, electrical orbit raising arms, and antennas. SES-14 will then be ready to start its journey to reach its final orbit in July.
We are still in the final phase of the mission, the unpowered flight phase. We're going to turn to the SILDA now. That's the Ariane launch system. We mentioned Ariane 5 is known for its double launches. She's the only commercial launcher capable of lifting 2 heavy satellites. We've done hundreds, and each one requires the SILDA, the black bell-shaped structure on the left again, which lets us carry a second satellite. This morning at the briefing, Stefan Israel told the crowd that this launch is actually 2 launches, and of course, he's right. You'll hear the DDO call out separation of the SILDA in a moment. There are several versions of it available, ranging in height from just under 5 meters to almost 6.5 meters. Tonight, we're using the long version, 6.4 meters. As with SES, our final film tonight is going to take a look at the relationship between Arianespace and Alya 3, a newer relationship, newer teamwork than with SES-14. We're also going to look at its first moves after separation.
The Alya 3 spacecraft launch campaign is going very well. We have had excellent support from the orbital, Arianespace, and Kourou Space Center teams, and the campaign has been running very smoothly. We are particularly impressed with the planning and execution of the various steps of the campaign, and are very happy to see the way the various teams work together. The Ariane 5 rocket will inject us in a super-synchronous orbit with an apogee of around 45,000 kilometers. Our LEOP campaign involves 5 separate burns of the liquid apogee engine, which will gradually circularize the orbit and bring us to the geostationary orbit. The final burn will take place about 1 week after launch, and will be followed by the deployment of the solar arrays, the antennas, and the electric thruster pointing assembly. A short time after that, we expect to reach the in-orbit test orbital position at 17.5 west, and currently foresee a full IoT campaign for the payload, in addition to a few days for the bus tests. Upon completion of the IoT, the spacecraft will be relocated to 20.1 west, where it will allow us to start system-integrated tests for the whole Alya 3 system.
We are 2 minutes from separation of the SILDA. This final phase is complex because we have to separate the 2 satellites and the SILDA in 3 different directions, as we mentioned, but we also have to release them at 3 different altitudes. SES was separated at 992 kilometers up, and the SILDA will be released at about 2,300 kilometers up. And finally, Alya 3 will go in yet a 3rd direction and a 3rd altitude, roughly 2,700 kilometers up, all this to avoid any risk of collision, of course. Alya is the 2nd satellite launched by Arianespace for the United Arab Emirates operator, Yahsat, Alya Satellite Communications Company. Alya 1, or Yahsat 1A, it was also known as, went up in April of 2011 on Flight 201. Its co-passenger, oddly enough, was another orbital-built satellite, Intelsat ND. The flight was also a world record at the time for commercial payload mass in geostationary transfer orbit, 8.9 tons in those days, since passed by Ariane, of course. Yahsat 1A weighed 5.9 tons compared to tonight's 3.7 tons. The SILDA separation was scheduled for plus 33 minutes and 19 seconds. Alya 3 is due to separate in another 2 minutes. This coasting phase, also known as a free-flying phase, as we approach separation of Alya 3, Yahsat headquartered in Abu Dhabi. It's the first company in the Middle East and in Africa to offer K-band services. They're available on both the two earlier satellites, but this band coverage will grow to an additional 20 markets with Alia 3, so it's a very important launch for the Abu Dhabi group tonight. It will extend coverage to 60% of Africa's population, and to over 95% of Brazil. In all, some 600 million people will have broadband internet services thanks to the new satellite. Built by Orbital ATK, it is the 27th Orbital ATK satellite to be launched by Arianespace, and there are another 3 orbital satellites in the Arianespace order book. About a minute to go, less than a minute to go, until separation of Alia 3. Arianespace coming off a very successful year, 11 launches, 20 satellites orbited for a total of nearly 54 tons total mass. In addition, the company signed 19 new contracts, including 3 for the new Vega C updated launcher, which should start flying next year, and 2 for the new Ariane 6, whose maiden voyage slated for July 2020. And the latest news on Ariane 6 last week, January 18th, saw the 8th successful burn of the new Vinci Ariane 6 reignitable engine. Separation of Alia 3 scheduled at plus 3504 out over the Indian Ocean and separated with a longitudinal spin, unlike SES-14. We are awaiting confirmation of separation of the satellites. You recall we didn't hear the DDO, so we are waiting, checking with the downrange stations. You can see the teams in consultation. While we're waiting for confirmation, which may take a minute or two, we may go to a film. We may not go to a film. If not, while we're waiting, there are currently 58 launches in the Arianespace order book. 18 Ariane 5s, 15 double launches like tonight's, for 30 satellites to go into geostationary transfer orbit. There are also the first 2 Ariane 6 launches which are ordered, 29 Soyuz, 9 Vegas, including the 3 we just mentioned for the Vega C. Vega C, C for consolidated. We are waiting for confirmation of our satellite separation. Remember our mass at liftoff, 773 tons. What's left of that, do you think, after satellite separation? Take a look. The vehicle lost 220 tons of fuel in each booster. That was 2 minutes after liftoff. There are fine drone pictures again. We're excited about the drone, as I mentioned. It's only the second time we've used the drone. If you were with us in December for the flight of Ariane 240, the Galileo launch, we used it for the first time. Drones, I learned today, you probably know, are waterproof, and they can resist winds of up to 70 kilometers an hour. That's pretty good for Kourou. As we're waiting for confirmation. We're going to go to either a film or we're going to take a break while we're waiting for confirmation, I do believe. We'll be back with more of the mission shortly, so don't go away.